Hey everybody, the screencast tonight is going to be on something called redox reactions. Redox reactions are when an atom undergoes a reduction and another atom undergoes an oxidation. A reduction and oxidation has to do with the change in charge of an element in a reaction, or the oxidation states, which you just learned how to do. So for example, the Statue of Liberty here, pure copper has a charge of 0. Over time, she changed to a copper plus 2 charge, and that has the green color. So it went from the copper color to the copper plus 2. Since the charge went up, we say that it is oxidized. Now, if something's oxidized, something else has to be reduced. We'll talk about that more in a couple of minutes. Any battery has an oxidation and a reduction happening within the confines of the battery. It's just that the electrons that are being lost by one thing travel through a wire and then enter into the battery again to be used as a reduction. But any of these, the oxidation of fruit and the changing of color, the combustion of the fire here, the rusting of the iron, the battery, and the change in color of the copper on the Statue of Liberty, all have to do with this concept of oxidation and reduction, redox reaction. Here's another example that you can do at home. If you have any silver in your home that's tarnished, what's happened is that you've developed this compound, silver sulfide, on the surface. Now, silver sulfide, in the compound, silver takes on a +1 charge if you were to figure out the oxidation number, and sulfur is -2. The aluminum here by itself is 0. Remember, any element by itself hasn't gained or lost electrons to anybody, so it is a 0 charge. The silver is a 0 charge because it's by itself for the same reasons, but aluminum in this compound is +3, the sulfur is -2. So you've got two things that are changing charges. You've got the silver that's going from +1 to 0 and the aluminum that goes from 0 to +3. So I'm going to write those up here for a second. You have silver with the +1 charge going to silver 0. And then you've got the aluminum 0 going to aluminum +3. Now, I think it's pretty easy for you to understand that this is going from 0 to +3, the charge is going up. If the charge goes up, we call it an oxidation. If the charge goes down, it's being reduced. That is called a reduction. Oops. And if I could spell it correctly. There you go. That's a reduction. You can't have one without the other because one involves a gain of electrons, the other involves a loss of electrons. And as one gains, the other loses, and that completes the circuit. It's written out a little bit more clearly for you, but here is the definition for oxidation and a reduction. And I'm going to talk about this again in just a moment because I want to also explain the reducing agent and the oxidizing agent. So I'm going to rewrite that aluminum and the silver again right here. There we go. Now, when aluminum goes to aluminum +3, it does so because it has lost 3 electrons. Now, if you look at the charges, you have +3 here, -3 here, that adds up to 0, and it's 0 on the other side. Over here, this is going to be gaining electrons, in fact, 1 electron, so I can go from +1 to 0. So what's going to happen is any electrons that are given off here are going to go over to the silver so that the silver can be reduced. Because of that, since the aluminum is being oxidized, it's also helping silver to be reduced. So we can say it's oxidized or is the reducing agent. Same holds true for the silver. The silver is trying to steal electrons away from the aluminum, so it is going to be reduced, but we can say that it is the oxidizing agent. So the oxidizing agent is Ag +1, and the reducing agent is the Al0. Again, reducing agent is anything that's oxidized. The oxidizing agent is anything that's being reduced. I would suggest, much the same way that we did with temperature, if you see average kinetic energy, cross it out, you put temperature. If you see reducing agent, cross it out and write oxidized. If you see oxidizing agent, cross it out and write what's being reduced. And that will help you to keep these terms straight and in your mind as you're solving the problems. The other thing that you can do is use this mnemonic to remember what's gaining electrons, what's losing electrons. Um, Trying to just erase this for you. So if you use this mnemonic, it's Leo the lion goes grr, Leo grr. And in Leo grr, you have lose electrons and gain electrons is reduction. So Leo, lose electrons is oxidized, and grr is gain electrons is reduced. So if you're having trouble remembering, does it gain or does it lose electrons, Leo grr might help. Okay, here, we're looking at how those electrons are transferred from one to the other. So let's first take a look at this atom. This atom has a charge of 0, and this atom has a charge of 0. In this reaction, A is going to go to A with a +2 charge. B is going to go from 0 to a -2 charge. So the B is going to be reduced, and the A is going to be oxidized. Now, how does it become oxidized? It becomes oxidized because these two electrons leave and find themselves on the B atom and the end. So these electrons, even though it's being oxidized, is called a reducing agent because A is going to give its electrons to B so that B can be reduced. So the reducing agent, again, is oxidized, and the oxidizing agent, because it's stealing the electrons away from A and helping it be oxidized, the oxidizing agent is reduced because it's gaining those electrons. Okay, so just remember that those are opposite terms. In a battery, this is how it works. Here, this was a 0 charge for the zinc, and it's +2. It's lost 2 electrons. These electrons flow through, go through the toothbrush, and then back down and into the battery, where it will then reduce the Mn from +4 charge to a +3 charge. So again, the electrons go from the zinc where it's being oxidized, loss of electrons. So this is oxidized, and we have a loss of electrons. And then the electrons go through the toothbrush, do some work, and when they get to the Mn is reduced. And so the Mn +4 is also called the oxidizing agent. But it's that ability to use those electrons to do work before they get to the reduction that's really important, and that's how batteries work. So the electrons that are being lost by one are gained by the other. I don't know why that keeps on switching for that slide. Sorry about that. Okay, now the other thing that you're going to have to be able to do is take a look at a formula and say, is that equation representing a redox reaction or not? And basically you're looking for things that have a change in charge. Any double replacement reaction where things just switch partners, see this OH didn't change, it stayed the same, so those charges don't change. Nitrates don't change, they're staying together as the polyatomic ion, so their charges are the same. This is a +1 charge, this is a +1 charge, this is +1, this is +1. In any double replacement reaction, there is no change in charge, so that would be no, it is not an oxidation reduction reaction. Now, how do you determine an oxidation reduction reaction? Well, here iron is by itself. Any element by itself has a 0 charge, so they're both 0. But then when iron is with the compound, it's something other than 0. You don't even have to figure out what it is. You know it's gone from 0 to something that's not 0. So you can say, hey, guess what? I know that is a oxidation reduction reaction. If you do have to figure out the charge, you know that sulfur is -2, so this one must be +2. So the Fe0 is going to be oxidized, but the S is going to be reduced. But again, you didn't need to figure that out. You just had to know it was 0 and something else to know if it was a redox reaction or not. In the next reaction, again, we have nitrate. It doesn't change. We have the iodine. That doesn't change. This is a double replacement reaction. So any double replacement reaction is no. The charges stay the same. They just switch partners. The following reaction, we have 0 and 0. So copper was 0, and now it's in a compound. It's something different, so it must be a redox reaction. And here the silver was in a compound and now it's not. There's your other thing that's changing. So you have two compounds that change. One, the charge goes from +1 to 0, it's reduced. Here it goes from 0 to +2, it's being oxidized. So there's your oxidation and your reduction. What I'd like you to do is try the final four here, and then when you come in tomorrow, we'll go over them. Have a great night.